So we are going to talk about the blockchain technology today. Don't forget to subscribe, yeah? All right, so first off, what is blockchain? We've been hearing so much blockchain. What is a blockchain and how does a blockchain work? All right, so let's take a quote from the founder of Dataflock, Mark. He said, when we have smart contracts on the blockchain, it can result in decentralized autonomous organizations or organizations without management or employees run completely by code. That is quite interesting, right? Let's see what all this means coming up. All right, so let's clear a myth that's out there. It's a general misconception. First off, blockchain is not the same as Bitcoin, even though most people think otherwise. So you hear people throwing about the terminology interchangeably. It's wrong, right? Someone say, okay, I want to buy blockchain. Instead of saying he wants to buy Bitcoin, they are two different things, right? So for our understanding, let's say blockchain is the technology, or shall we say platform, on which Bitcoin is built. So blockchain is bigger than Bitcoin. Bitcoin is just built on blockchain. Can we say that? All right. So we have something we call the Bitcoin blockchain. We have the Ethereum blockchain. We have the Litecoin blockchain. That makes sense, right? So cryptocurrencies work on blockchain. All right. So we've cleared the myth. What then is blockchain, right? So first off, let's say blockchain is a digital record, right? It's a record of transactions, just like a traditional ledger. So if you have any accounting background or you've done some accounting before, you know, to record a transaction, we have different types of ledgers. So we have the sales ledger, we have the purchases ledger, we have the returns inwards and returns outwards ledgers. Those are for the accountants, right? But a ledger basically records transactions. It tells you what has moved from where to where. Now on the blockchain, it's a digital version of a ledger. Let's say that for now, right? And we're saying these transactions can be a movement of anything of value. So it could be money, it could be title to land or property, it could be votes in an election, it could be records in the hospital. Anything of value can be recorded on the blockchain. Next off, it is secure. So information stored is impossible to modify without someone detecting it somewhere on the network. So we call this the principle of immutability. You cannot change something on the blockchain after it has been recorded. That is a key feature of the blockchain. And most importantly, it is decentralized. So we have no need for a centralized body. The transactions are verified by consensus of multiple users. So once we have the transaction recorded, we don't need a central body to regulate or to monitor the data. Every member of the blockchain network has access to this data, and by consensus, by our common agreement, we're able to verify this information. Now, how does all of this work, right? So a blockchain needs to do two basic things. First off, is to gather and order all data into something we call blocks, right? And then chain these blocks together using a principle we call cryptography, right? So if you can see just three blocks here, block 0, block 1, and block 2, you can see they are connected by one common thing. Look at the hash, right? So let's check for block 0. You can see the hash ends with 55. Come to block 1. You can see it has, on the last line of block 1, you can see previous hash. It's the same hash in block 0 that has been repeated in block 1. Now go to block 2. But before that, look at the hash of block 1. Block 1 ends with DEB. Check block 2 and you realize that the previous hash is right there. So this is what cryptography does. It links all three blocks together using a common principle. This is why you cannot modify data in block 2 without block 1 and 0 throwing up an error. You can't change data in block 1 without block 0 or block 2 throwing up an error, because they are linked by a common chain. This makes it secure. Now let's look at the transaction. All right, so let's say Lesnar wants to sell his land to Reigns, right? So what's the first step in this typical transaction? So we record and we share this transaction with other members or other users, or let's say other computers on the blockchain. So once there is that transaction happens, we record and we share with everybody. Now what happens after this? Now, on the blockchain, this record is combined with other different transactions into a single block. Now, think something like computer databases. So, if you look at the blocks we have on our screen here, we have transaction 1, transaction 2, transaction 3. Let's assume transaction 1 is a transaction between Lesmer and Reigns, where he's selling his land to Reigns. So, this transaction combined with other transactions, probably someone wanting to buy a car, someone wanting to send money to someone, vote in an election, record in a hospital, anything you can think about, right? These are put together into one block. Now, the transaction in the next step is time stamped. All this means is that we put a time on the transaction. So if you look at the first block, it shows the time of what? 12 noon. Block 2 shows the time of 12:10 p.m. Block 3 shows the time of 12:20. Now, every transaction is time stamped. Then when the transactions are combined into a block and the block is filled, the block is also time stamped. Now, this ensures that information stored in the blocks is sequential and no one can duplicate entries because of this, right? Then in the next step, we send the completed, the whole block to the network. It goes out to the network and then we append it to a chain. If you remember the hash we talked about earlier, where block 1 has the hash of block 0, block 2 has the hash of block 1. This is what we mean when we say it's appended to the chain. All right, so at the same time, others may be sending out their blocks. We don't have a problem with that, but the time stamping ensures that the blocks and data is sequential and everyone has the latest version. Don't forget, it's decentralized, so at every point in time, whether you are in Nairobi, whether you are in the UK, whether you are in the US, whether you're in Canada, you have the same version of data. All right, so you're seeing the hash. It involves some cryptographic math you don't want to know about. It's generated as a unique string of characters to secure or lock every block. So the hash is used to secure the block. Now, in the next step, we say the hash from one block is added to data in the next block. So any attempt to alter a previous block will raise an alarm, right? Because the hash won't match and everybody will be notified that something has changed. And then we'll go back to the version we all agreed on before someone tried to modify the network. This makes the blockchain very, very secure. So if you watch this one, you can see that the hash of the previous block in block 1, watch it in block 2. So you can see in block 2, we have hash of previous block header, which links to block 1. If you watch block 3, the hash of block 2 comes right there. Now in the next step, we say, okay, because all participants have a copy of the entire blockchain, they can detect anyone who attempts to tamper with the blockchain. Now the transaction is complete. Reigns is the new owner of the land and no one can